Good morning, good afternoon, good evening. I am Divakar. I head the QA and testing practice here at Trigent. And today's topic is an interesting one given the fact that we are in the midst of seeing an AI revolution, so to speak. And with all things AI, there is a lot that needs to be done from a perspective of why current data set practices are not sufficient, right? I mean, is testing that we're doing for the AI models. We've seen a lot of application of AI, but getting the model itself working, is that sufficient? Let's take a look and find out, okay? So just to get in touch with enriching your webinar experience, one of the things that we think is good as a participant, you will be on mute throughout the session. The expected duration is about 45 minutes, give or take 5 minutes here or there. But we will put aside time for the Q&A at the end. So use the Q&A pane on the right on your control panel. Simply type in the question, click send, post your questions at any time, not a problem. We also have a couple of polls and surveys that we would like your participation in, so that we get your feedback in terms of exactly what So if we need to change the course of the topic, we can do that as we progress. Just a brief introduction about Trigent. Trigent has been is an IT services provider that's been around for the last 26 years now, essentially helping solve the digital transformation challenges for our clients. We work across a wide variety of sectors, banking, finance, transportation, edtech, high tech, etc. We've been nominated as amongst the 10 most admired companies. All of our customer feedback is available on Clutch. That's where all of our customers put all of their feedback into the public domain itself. So, and we've been nominated as a top consultant in Clutch. Last year, we were declared winners of the North American Software Testing Award for the best agile project with our customers, and we have mentions in the Zinnov zones as an enterprise R&D services. Our QA and testing practice, as we call it, is a full services stack that works across QA consulting. Customer experience is the benchmark, is the key focus around which omnichannel experiences, performance, as well as security is really is underpinned. And we are reasonably adaptive. Our workforce is largely based out of both India and the US. And we are also host to the Women Who Test chapter of Bangalore. The Women Who Test chapter regularly does events, webinars, learning experiences in different forms. It's got technical topics, it's got developmental topics, it's got topics around theater, and it's a fun 1 hour once a month usually. Check out our WWT page, do register. I mean, you need not, while it started off as a Women Who Test and encouraging women to come back to the workforce, we have noticed that the panel, that the audience is fairly mixed, and that's good. And people use it as a learning opportunity. So coming back to today's topic, what are the best ways that are the current practices that we use to test AI sufficient? I have with me Dr. Srini. Dr. Srini is good to meet you, Dr. Srini, and he is a PhD in artificial intelligence from the University of Alberta in Canada. Very distinguished. I don't want to read out his entire resume. I think the rest of the webinar will go off in that. So Srini, I'm going to keep it short. It's been really nice interacting with Dr. Srini as a part of our partnership with testing, and it's been a good learning experience for us. It's been a good way by which we within Trigent, are able to take testing's product, bundle it into our services, and be able to help improve our the testing that we do for our customers at the end of the day. So Dr. Srini, without much ado, I will hand this over, and all yours to introduce yourself, to introduce testing, and we can get started from there on. Let me just make you presenter so that you are in charge now. All right. Yep. Dr. Srini, I can't hear you. I'm not sure whether that's me or whether it's you, but.
So can you hear me now?
Yes, I can. There we go.
Okay. So thanks, Diwakar, for this opportunity. It's been a pleasure working with you over the past few months. I'm glad to see, initiatives from Trigent about, women who test, etc. So about our company, testaing.com, if you see, there is a subtle A in the word testing. So we are primarily a testing company, but we focus on the AI testing. So we are recognized as top 10 emerging analytic startups in India recently. It gives us great pleasure to, take a quick look at the recognition of the work we've done, though we are a fairly young company. So in terms of the company, it's about 2 years plus. We just finished 2 years since inception. Our focus as a company is basically to provide solutions for AI testing. So our leadership team comes from, a comprehensive background from testing and AI. I myself have background in AI, having done PhD in AI, been in AI since 1988, been following the whole world of AI, seen the transformation which happened in late 2000s with lots of excitement in the AI world, and happy to see AI come to the forefront of the world. So I've been waiting for that. So, and then our other co-founders are experts in testing. So the two minds met, and Vipul, who is the CEO, who is the president of Indian Testing Board, and our team worked together to actually come out with this company. And our focus has been primarily from day one to look at AI testing. The way we started is, if you look at our AI testing certification called AI United, this is something where we started around 3 years back, and that's the starting point. And we were amazed at the success of this certification. We have actually got around 1,000 plus people certified, all testers across the globe, 8 countries, translated into 7 languages, and it's going great guns. So once we do that, the expertise we figured out in building the certification also got us into feedback from our learners saying that, oh, you're doing this, but why don't you come up with a product in this area? There is a white space. And that's when we went back to the drawing board, and around a year and a half back, we started deliberating on what should be brought out. And then that's where we said, okay, there's a lot of testing which people do already, but what is important is, if you really want to create a scalable, deployable, and acceptable AI, that's where a lot of issues are being seen. And that's where our marquee product, AI Insured, is geared up towards. Our idea is to create a product for safe, trustworthy, and responsible AI. So that's like a brief background of our company. Our philosophy is very much driven about everything that you deploy in a context of any human consumption, be it in healthcare, be it in driverless car, be it in finance, anything. I think we should have a warranty or a guarantee that the product we're doing with AI is trustworthy, responsible, safe, so that it increases the acceptability of AI and also helps us in leveraging greater value from AI. So that's what our goal is with our product and solutions. Thank you, Diwakar, for this opportunity.
All right. Yeah, perfect. Srini, thanks for that introduction. It's good to have you here today. In fact, having dabbled a bit in terms of trying to implement AI for testing, what I did encounter briefly, I mean, this is the first time, some time back after we met you all was when we were really looking at testing of AI models. But before that, we did implement AI in testing. And one of the things that struck me was that, the common myth that seems to be around that was that, AI models are difficult to test. I mean, they're continuously evolving. And unlike the standard way by which we test a lot of our business rules, which have very defined outputs, the outputs from AI can be ambiguous. I mean, it can be an A or B or close to A or close to B, but it isn't always the same response. So what, according to you, I mean, when you look at the approaches that are being followed, because we're saying that, the AI models or the way we approach testing is insufficient, what do you think is happening currently that is being followed to test AI models?
Thanks for that question. So I'm not saying that there is no testing currently. There is currently a testing process in the overall life cycle of AI. So if you look at, this is a very well-known standard process, which is what we call as cross-reference industry standard process for data mining, which is basically the underlying process of end-to-end, AI from, you can say, cradle to grave, right? Where you start with acquiring data, you prepare and clean the data, and then you kind of iterate between different modeling approaches and try to come up with the perfect model. So during this description of the evaluation phase, there is a lot of work that is happening in the current data science process, which are the basis for the AI process to test AI systems. So there is definitely a notion of testing in the AI world, and the way it works is that they take a portion of the, whatever data you have acquired and cleaned, to keep it aside, and then what you do is you try to find out the evaluation by checking different combinations of different model hyperparameters or different model variations, and see how the models which you generate by variation of the different inputs, how they are basically affecting the overall approach to handling the correctness or accuracy of the model with appropriate metrics. So evaluation is done by taking variation of one parameter, try the metric. Like in classification, you look at accuracy, or in regression, you look at R-square. And the point what you do is you try to iterate over several hyperparameter variations and see by checking how they perform on this portion of the acquired data, we call it test data, set aside and see how it performs on it. The randomness of the test data is what gives us the guarantee that the current model will scale well in the future. So actually the validation and the test data which is carved out from the original data randomly is like simulation of the new data that's coming. But the problem is that sufficient? That is what is the question we are trying to answer in this webinar, and will be the focus in our case.
Okay, so that's awesome. I mean, let's take a step in terms of I know I don't want to help you jump the gun, but let's find out from the audience as to what they think are some of the parameters that they think are missing in the current AI testing. So folks in the audience, I have a poll out coming for you, which is help us answer this question, and then we can we can take that forward. So there's no fastest finger first award, but it'll be good to get your view of what you think is lacking in the current process. Okay. All right. So we have only 20% who have voted. 30 now. Come on. Good. I'm seeing the answers also shift around. This is interesting, Dr. Srini, if you're noticing the way the answers are moving. It's okay. We give you another 10 seconds, 20 maybe. I think one of the key things that we're trying to achieve from this is not test your understanding. It's just to I'm sure all of us have experienced using AI systems or have been subject to AI. If anybody of you all have watched Netflix, Prime, just the way that they're throwing up choices that you should watch next, or what comes in the email, is again a lot of AI. So you have been subject to AI, whether you know it or not, and it's good. So good. So we have about 60%. I'm giving it another 65, another 5 seconds more, and then we close the poll. Okay. All right, that's good. 70%, 77, 80. Good. That I like this. This is interesting. Okay, so let's close the poll and let's look at the results. It's interesting that people have been equally divided across all of these. I mean, in a way that to 50% of the audience, it's explainability. 50% of the poll respondents have said security. 60% have said bias. 40% have said privacy. Your take, Srini, on this?
Sure. I think that's a good heads up to my dovetailing into my views on the overall perspective of the idea of what is happening in the world of ML. See, one of the things which is sad is the increasing accidents in AI. And this is not increasing even as you speak. There are chronicles of AI accidents in the field. The issues we see in terms of impact of AI accidents could be as grave as loss of a life, like you remember the Uber driverless car hitting a pedestrian, right? Or it could be based on a very well-defined tool for hiring having to be withdrawn after lots of investments because it's found to be biased. Or a chatbot intended for public consumption turns abusive because of poisoning of the data. Or in some cases, it could be not so critical, but it could be, diagnosing the data wrong, classifying wrong. So in general, there are issues, as you saw in the poll also, right? There are issues like there is lack of complete coverage and rigorous testing. That leads to a lot of this. At the same time, we also need to see that when you talk about testing, we need to ensure that there is all these issues about coverage in terms of the comprehensive testing being covered. And also there is a need for explaining the decisions, especially in compliant oriented environments like insurance or healthcare. You cannot just trust that there is a very complex black box AI model, the deep learning model, which has gone and taken decision to reject your credit card. Will that be enough for a customer? No, right? So you have to bring in explainability. At the same time, lots of things, like you saw the poisoning example. Today, there's lots of examples where simple models have been poisoned and caused the AI systems to fail. So when you look at all of this, we also looked at the statistics about this, and this is staggering. And this is actually not a good scene, especially at a time when AI is prime for consumption for digital transformation. You don't want concerns like 76% of CEOs concerned about lack of transparency, which is what you guys point out, like explainability. Then we looked at potential of bias. This again example where you saw big tools being brought down because they were found biased, and a lot of failures being reported by AI deployed applications. So these are not good things for us to talk about. So when we talk about the overall approach to all of this, so we created a laundry list, and what are the issues in terms of to be tested? We got 4 of them, right? Where you saw about security, which of privacy, we talked about bias, we talked about explainability. But what we feel is there is a need for a end-to-end testing of the diverse attributes related to quality assurance, and making sure that we avoid AI accidents in the future. So by doing that, we also want to tell you one thing: the international community, especially the standards community, is also extending notion of quality itself, which is beyond the conventional ISO 25010, which is about the testing performance or stability, reliability, etc., to newer quality dimensions for AI, like transparency, bias, and fairness. So it's important that there is a realization that we need to extend the notion of testing for all of this. So if you look at from an overall perspective of what it means to look at the different kinds of testing, what we felt is, if you take a runtime view of the whole life cycle of AI, which is what we saw, the previous was a small version, right? Data acquisition all the way. So if we expand it, we see there is a data input, then there is data crunching, manipulation, transformation, etc., and preparing it for the training process. And then data scientists come and try different models, evaluate based on the conventional metrics like accuracy, etc. And then you have a final model which you go and deploy. But where we see concern is today the conventional metrics like accuracy, F1 score, etc., which are what they use for selecting the final model and be going to deploy, is not enough. So what we say is there's a need for interventions at multiple layers. First, at the data level itself, we could see that data adequacy or data bias is something which is the source of potentially problematic models. So we need to test for bias and test for data quality right at the starting. See how is it quality data or is it biased data, etc. Then after the model, data scientists come in here. So here we take an approach that the independent AI model testing is an augmentation to the data scientist. It's not about replacing data scientists. It's about helping the data science process to overall deliver a better AI model. So when you say we talk about model testing, we talk about areas like, how we can check for security of the model deployed. Can it be fooled by somebody by poisoning? Can you detect that? Can you help create explanation for the generation of the solution based on the kind of model, the decision it takes? Can you generate explainability? At the same time, we also look at, is there any leakage of the data? Especially in compliant environments, private data being leaked is a big thing. And if AI models are, without your knowledge, leaking private PIIs, it's a dangerous thing. And last but not the least, corner cases, especially when you do training, it may be that you have collected good amount of test data randomly, but it's still possible that there are corner cases which you have not covered. And that is why we try to look at testing for adequate coverage using concepts like white box coverage and metamorphic testing, which is more like a pseudo-oracle implementation. That is when you do the testing for before you deploy. And then the result of this should be used to further take through the life cycle right from data all the way to. So for example, if you detect bias, that's not acceptable. So you go back and redo with bias aware, remodeling or redistribution or resampling of the data, and then run the model so that it passes the bias test, that is unbiased. Or you do coverage based on that and you found corner cases. So can you retrain the model with these corner cases so that you get a more robust model which is robust for the corner cases? If there are security attack vectors you detect, can you make the model robust to security? So it's not like we're projecting only the testing, but output of the testing should lead to the data scientists go back and redo the pipeline with handling a better report. So in the next iteration, we are hoping that it will give a better quality, covered all the corner cases, handle security attacks, handle privacy issues, and handle what we call as uncovered areas, and handle the bias issue. So that is the goal. But that's not enough. When you go to deploy it, after deployment also there are issues like you have to manage performance, and not only manage performance, but you also manage the end-to-end maintenance of the quality of the model even after multiple days, multiple months. The point is, at one point when you train and get the model, it captures the truth at that point of time, but maybe the underlying data has changed some kind of distribution, and that may lead to what we technically call in OS terms, right, called thrashing. Thrashing means maybe it leads to more detailed, poisoned, or reduced accuracy. So we need to have live and performance tests and model testing of different kinds. So that's what I say is what we try to aim when we talk about generating a set of tests for all of these different life cycle of the ML with different interventions at different points.
So as per, just to kind of go back to the poll question, there has to be an equal emphasis on all those 4 parameters that we had put out there. as a part of your testing, and not just, you know, not just one or the other. So all four, like explainability, security, bias, privacy, are just as equally important, depending upon the context in which you're actually deploying. Right. Good. So let's again, coming back to you brought up some interesting points around explainability, for example. I think there's a lot of a need to understand how the AI model has probably arrived at a set of outcomes, given a set of inputs that it has received, right? I mean, maybe it's my viewing pattern on Netflix based on which it's throwing up recommendations for movies, right?
Correct.
So how does one build that ability to prove, or disprove the feature set, so to speak, that contributed to, the AI model's decision making? How do I, given that the model is and the way that the model is built, it's there is a lot of scientific basis that goes on. There's a lot of neural nets within that and hyperparameters that kick in. How do you get a model to explain its decision to you, and how do tools like AI in short, for example, support a data scientist to be able to make that explainability come to the surface?
Thanks for the question. Today, I think among all the tests we described, explainability is probably the reasonably well understood now because of the repeated requests from governments, from companies to make the whole black box big models open up. So it actually started with US DARPA. They started this project around explainable AI around 5 years back. They said, while AI is getting great guns, but we need to be able to, when you trust a doctor to be replaced by an AI program, we should have equal confidence in the AI program like we have in our family doctor. So to do that, what explainability came up as a kind of a test stage where they said that, okay, we won't give away the benefits which is coming from having complex deep learning models, black box. But what we will do is we'll work as a post facto analysis. The way the post facto analysis works is if you look at a particular, let's say, example. So what we do is we kind of look at any particular example and we try to look at, let us say, we have taken an example which has been misclassified, which was actual class was say 2, but you predicted 0. So we try to look at creating a retrospective way of looking at the data and find out what part of the data is it focusing on. So if you look at this particular example, the focus is on the green part of the model, which is why it's giving a wrong choice. So what our focus is, what part of the data is the model looking at? That is the main focus when we talk to look at the specific instance where the model has failed. Or if you look at this particular example, there is a definite focus on these two parts related to around the face and of the so-called deer, which is what it's trying to use to predict a wrong class. So what is happening is in all of this, you're getting clues from analyzing the data by understanding what part of the image is being concentrated. So we can look at two things, either look at the negative decisions and map it back to the data, see what part is it working towards in terms of contributing to the decision, or you can also look at correctly classified data also. So it's not like we only look at incorrect data and get values. So the way explainability would work is it will give you the like an open book. Then it's up to the data scientist to understand the kind of quality data they have to collect to make it better. So in case of image, it was very clear, right? You could point out the basic location in the image which the model is focusing on. But in case of, in structured data, let's say, for example, we talk about structured data, which is taking a output decision. What we do is we try to find out what is the relative contribution each feature makes or each individual column makes. And that is what gives us an idea about the particular model having stressed on these particular attributes as a more important ones. So this again gives the feedback to the data scientist, saying that you can go back to the domain guy and say, oh, is this the intended importance in terms of features, or do you think we need to change the data quality in terms of getting more variation in more sensitive variables, which are supposed to be more important than what the model is currently looking at? So the way explainability works is it tries to construct an after explanation of the decision. So that is to be interpreted by the scientists and the domain guys to accordingly do the transformation so that they can get a better expression. And nowadays, what is also happening is, in fact, in some countries, they're saying in the AI model, along with the model decision, you also submit the explanation. So it's getting to be now part of the overall lifecycle process. So I'll probably in 6 months time to 1 year, I'll change my data science process saying that, oh, don't just put the deploy thing, but also add the explainability as part of that and get it as part of the report you're supposed to report. So hope that kind of explains the importance of explainability.
Absolutely. I think given that there is so much, I mean, Netflix is not something that affects your life in any way, but you know, it in the sense it's probably just affecting your entertainment value. But given that there is a lot of AI that's being used in healthcare and arriving at decisions in terms of medication, course of treatment, etc., all of these, what you mentioned is probably, and no wonder regulation is now stepping in very intensely into doing that. Thanks for that, Srini. You know, one of the other things that you happened to mention before was the fact that you talked about metamorphic testing, right? Which just to put it in context is about when a test oracle undertakes a certain decision or produces a certain outcome with a certain value or certain inputs, how does, if that input changes in some relation, does the output also change in a corresponding relationship, right? So the question is, how do these tools, I can visualize it by changing the data points, but I know that now, given the fact that we have to keep track of what inputs we use, how we use the inputs, what are the corresponding outputs, how does AI ensure help us to do that in a much better and much cleaner way?
Yeah. So thanks for that. I think what we are solving is one of the very fundamental problems with integration of AI and testing. See, in testing, when you do normally functional testing, in a lot of domains, you have the luxury of test oracles. When you do functional testing of a C program, you know what the expected output is for that program, and you try to kind of look at comparing that with expected. You run an automation script, you get a report, which of the tests are failing, and you get back and see what you can do from analysis. But in context of AI, problem is you don't have an oracle itself because it's a probabilistic approximation of the pattern in the input data. So when you have that, you don't have exact pattern which you can try to compare with, because there can be millions of variations which you can try to model. Somebody will say this is the better model, then otherwise say this is the better model. So what we try to look at is, instead of considering an oracle-based approach, we try to simulate the oracle by saying that instead of comparing Y, which is expected output, with exact ground truth Y, instead of that, we come up with metamorphic relations, which is basically, you can say that if you do transformations on the input, we expect certain transformations on the output. Let's say, for example, you have a set of numbers and you say you want to compute the sum, which is the output. So permutation of the numbers could be done and still the sum could be same. That could be a metamorphic relation. So in the context of machine learning, what we're seeing is, if you take the image, let's say data, you're talking about, let's say take the image context. We take the image data, we try to perturb the data with transformations which are very commonly done to make it more real life kind of data. Like we change brightness, we shear, we change translate, we kind of look at rotation. And then what we do is we try to do a systematic mutation of the original data and see that our metamorphic relation, which says that the accuracy of the model should not change significantly if we try to try the model on various systematic mutations of the original data. So then what we do is we try to find out corner cases by finding out what transformations out of different possible transformations on the input data across the different classes are actually not being handled adequately, and there's a significant change in accuracy. That means that that particular part, kind of transformation is probably not present in the real life training data which has been given. So what we do metamorphic testing here is to substitute the lack of oracle with a metamorphic relation based pseudo oracle. As we speak, we are building the world's largest metamorphic testing collection across all kinds of input data. We're doing it for, let's say, for example, I want to show you another very upcoming area, which is kind of it's a very brief what we have started, but we're very excited about it. So, for example, people must have talked about a lot of object detection in videos, right? So what we are trying to say is, can we perturb the object detection by trying different kind of transformations on the original? For example, what we're doing is we're trying to change the background color, or we're trying to rotate the image in the video, or we're trying to bring newer objects. So we're trying to do different metamorphic relations on the original transformation and see how the object detection model is still performing with high confidence or not. So our goal is to make sure that we will create the world's largest pseudo oracle for any AI applications. We are very gung-ho about it, and we're seeing very good results because it's really yielded corner cases, which customers were so surprised that these corner cases have not been tested in our actual training data.
Okay, cool. That sounds interesting. That the fact that you can actually manipulate the data to simulate what we might call the what is popularly in testing also known as negative tests and positive tests, so to speak, right? I mean, and all of that. Coming back to another area that you did mention, you talked about, and this is again going back to some level to explainability, but trying to understand, what feature sets. I mean, sometime back. Okay, let me take a step back. Sometime back, Facebook got a huge amount of flack because it threw up ads that were gender discriminatory, so to speak, right? I mean, they probably their algorithms recognized you as a person of color and threw up ads that were quote unquote inappropriate or to that extent, and they got a lot of flack around that. Now, my whole point is that this obviously means that there has been a certain bias that has creeped in either into the feature sets or into the data or into the way that the models was trained. When I, as a tester, want to look at the data and figure out, is there bias in that data? Is there is my outcomes leading towards a certain towards certain inappropriate results? How does one go about doing that, Srini, and how does one create that kind of a mechanism?
Yeah. So, there are two things here. One is about what we call as detection of the sensitivity of the model with respect to certain attribute. Then finding out if that particular attribute is actually a very sensitive attribute. So it's a combination of this which is the killer. So let me show what I mean by that. So when I look at detecting of a bias, so what I want to really find out is the model's fairness. It can be judged by some standard algorithms where you can look at if there is this orange color, which is right. This is basically called as feature dependence model, which describes that this particular model is very much dependent on kind of input data on age and the pay 0. These are the two columns. Now the problem comes not that it is sensitive with respect to that, but problem comes this actually smacks of ageism. This model actually smacks of ageism. This is a credit card model. Think about it, and it actually smacks of ageism. And the moment you talk about it being sensitive with respect to an attribute, out of attribute pay, I may not be worried because good pay, maybe you give credit card, that's good. But if it is discriminating with respect to age, this is a really red flag for me. So what this particular kind of testing for bias is indicating is out of the variables which are sensitive, which of these are actually being biased in this kind of a model. So the idea is because you have a variety of representations of age, and it may not be a good idea to have this kind of a discrimination. So what you do in this kind of a detection of a fair model is you actually go and you create some kind of a model where you can try to rejig the data, where a lot of data may be belonging to one class and others may be marginalized, and that may be a big cause for the bias. So what we do is we try to provide even techniques for indicating to the user, saying that this is the way you can go and reprioritize your data by rescheduling the way the pipeline should be run with a different proportion of the data, because it is possible that if you just go by, okay, I go as per the input data, you will go again to the, if you look at the, scenario we printed for Amazon. Why was Amazon hiring tool to be withdrawn? Because they did no mistake. They made the input data and the FairML indicated that it is insensitive with respect to the gender. So based on proportion of the data and the gender, male being dominated, they actually created such kind of a behavior. But that's not acceptable. So that is where you try to go back and redo the work on relabeling the task with such that you get higher priority to the underrepresented classes. And that is the fair way of looking at it. And as we speak, I'm not saying this whole problem is solved. Let me tell you, it's a very work in progress. This kind of, this is going to be a huge area of research. Even as we speak, lots and lots of work is going on how do you handle this kind of thing? How do you handle the actual biases? It may be sometimes not technically possible. It may be more about the process itself. For example, I'll give you, today, the whole world is gung-ho about, large models like the OpenAI, Code Pilot, or the, OpenAI GPT-3. But there is a strict warning. They have carried around the world biases into their tools because they have trained on world data, which itself is biased. So it is sad, but it is.
Cool. I think gives us an idea that, as testers testing AI models, I mean, there's a lot that we need to think about, not just from how, what has gone into data selection, but also what feature sets are actually contributing to some of those decisions. I just want to talk about another aspect that you did mention, which is really about, again, another incident where Google's self-driving cars were kind of fooled by some changes to the stop sign. For example, it failed to recognize the stop sign because of whatever perturbations that you brought into that stop sign itself, which caused them to completely ignore it. And it also led to the fact that models could easily be fooled. I mean, which becomes then an issue that on security and possibly as we go further, and we can speak about that, is also so how does one go about trying to test for the fact that the model is reasonably secure, that such perturbations do not cause hacks, leaks, etc. within their systems that it's being deployed in.
Correct. So welcome to very new world of hackers. There's a new generation of hackers in town. These are called adversarial hackers, whose goal is not to target web applications but to target AI models. So what these guys do is they take a simple image input, like you said, the example of stop sign, right? They just perturb it a little bit. If you look at these two images in this, the adversarial and the actual look so similar. It is just a couple of pixels. In fact, there are scenarios of 1 pixel attacks. And this is dangerous because what you see is the same model now is predicting the class wrongly for the small perturbation we did in the original. So what happens is there are lots of attacks which are happening on the real world data, and these attacks are getting more and more prominent, and the adversarial attacks are getting to be a bane for deployed AI models. So God forbid if people do not make an arrangement for testing for such kind of fooled, especially if it's sensitive, like suppose you're doing a cyber security related program using ML, or if you're writing a security using face detection, or some interesting strategic application using image or structured data, it is very, very possible that there are these hackers who will fool that into misbehaving, and it can be leading to really potentially bringing down the performance of the model in unexpected scenarios in which the hackers can come in. So I think what we try to do is we're trying to constantly scout the literature on different adversarial attacks. So we're constantly increasing that kind of a detection of the different attacks that are possible. So what we do is we try to detect the different attacks that are possible on the base images. Some of them base it on black box, some of them are white box kind of attacks based on the model. but we're trying to make a use of our knowledge of this domain to bring up a comprehensive, you can say, AI security testing kind of a framework. And what is sad is we thought these were for images, but I'll just show you a very counterintuitive thing, which blew me off. So when I looked at the images, okay, people talked about poisoning attacks, but it will be very, very surprising to see that a fairly simple structured data with 4 columns, you can see slight perturbation on the data can actually create adversarial examples. This is very, very difficult days we are going to see ahead, where hackers have something very, very big at hand. It could be simple, prediction model you built on 4 columns, and now you can perturb it by slight perturbation and cause it to misclassify. So this is basically the huge problem in the world of ML, whether it's structured. I'm sure the same thing is happening in some of the text-related scenarios, etc. So it's something we have to be careful about, and we have to bring a new regime of security testing to AI.
Perfect, thanks. That kind of scares me now whenever I think AI. No, I'm just going to jump ahead, Srini, in the interest of time, to one of the last points that we had talked about in our earlier poll itself, that about privacy, right? I mean, it's possible now that PII or personal information is actually can potentially be leaked by reverse engineering models. I mean, that's the new trend that's happening in, and this is an extension of what you talked about from a security perspective, right?
Correct.
Now, my question there really is about, how does one test for the fact that PII is, models are free of that, or at least the decision making or the data sets are free of that. Data sets do not leak that kind of information. That information cannot be reverse engineered, if at all it is being used at all. And those are again another set of challenges that data scientists would need to go through to figure out, how do they keep their data secure, how do they make sure that the right amount of data privacy is maintained at the end of the day.
Yeah. So let me turn it around. So what we propose is basically to test the models to see how they leak information by looking at how the privacy attackers get access to the different input training data from the model. And if the training data actually has certain PII still, which you have reverse engineered and found out, that is the scary part. Because what happens is a privacy aware machine learning process would actually do appropriate processes to de-anonymize, pseudonymize, or use some very cutting edge techniques like differential privacy, etc., before you go into the actual machine learning. So what we are trying to see is we are going to show what is the thing which the attacker is able to infer from the data, and if that data has, let us say this was about a car and it had certain license plate number, and that was a PII, right? It's an identifiable number, and that is something which it is not taken care of in the process of machine learning. So what our tool we're trying to see is 2-stage. First, detect what are the inferable training data by inference attacks. Then second stage, which we are trying to do, is does it actually have certain PII? So that is basically a twin combination. So the idea is we are trying to project to the community saying that there is a need to audit your models for privacy leakages. It's not like just because you're not given data, you're only given a model, that's not safe enough. It can be itself leaking data. So this is what I'm trying to do. This kind of attack which you do, and you find out that for each of the class, these are the kind of images we've been able to discover by just reverse engineering. And if some of them actually happen to have certain PII, this is a dangerous cause. So I'm not saying we have the perfect solution, because today in the world of privacy aware data mining, several solutions are coming up, like pseudonymizing attributes or creating differential privacy models. So that is up to them as to see how they have been taken care of. But this really points out and really brings out in the deployed model, is there actually some private information which has been leaked? So our goal is testing. It's not about solving this problem.
That's it. At least we can highlight that information. That itself should be good enough as testers. I'm again now going to jump to another part. We've heard of tools like Lime that's open source, that's available, that allows explainability. There are other tools that are now emerging in the marketplace. How does AI Ensured, compare with some of the tools that are available? Because I know that there are different tools that do different things for each of those things. So Lime does explainability, doesn't really talk about security. What are the other tools that you can shed some light on, Srini, that can compare, and where does AI Ensured stand with respect to some of those tools?
Sure. So we did a competitive landscape analysis. We found similar things, that there are enough tools out there in the market for explainability, like Fiddler Labs, or open source tools like Lime. But our goal is to think about the test approach to handle the 360-degree view of the quality dimension. So we taken an approach saying that we should treat any issues which can cause showstoppers in deployment. It could be about bias, it could be about corner cases, it could be about security, it could be about privacy. So from a 360-degree view, handling all kinds of tests, I think we're probably the one in the market with kind of a leadership, because as I said, we were the first to think about this, launch the AI testing certification. That gave us a lot of heads up. And we are also filing a lot of patents in very specific areas like metamorphic testing. We are probably the world's largest metamorphic testing library for AI systems creating pseudo oracles. Same way, I want to talk briefly about one small thing. This is again a huge new research area which we are very focusing on, is to generate corner cases by looking at the coverage criteria, which normally in testing we do code coverage, etc. Right? Here we're doing coverage of the models and looking at the neural networks, and we use concepts of neuron coverage, and using that we try to find out transformations of the original image which are triggering those uncovered areas in your model. And that is turning out to be a huge research area, and we're very gung-ho about these very custom corner case detection approaches. And lastly, just wanted to provide one more thing. We're not just doing auditing, giving you a report. We also want to provide a proof that if we take our input and retrain the overall pipeline by taking the corner cases, we see that it can be corrected. So if you see a typical example like this, earlier it was misclassified, but after we retrained with the correct corner cases in the training process, we found that it can predict correctly. So this is our offering. So we think we are definitely having innovation in this area.
Thanks, Srini. Lastly, I just want to say, anybody has any questions, please pose them now. Happy to take them as we get towards the fag end of this. One last question, Srini. I know that these are tools that quote unquote don't automate, right? I mean, automating AI, it would be good to hear your perspective. But there is great irony, as we were discussing before this call, in that whole statement of automation of AI. My question to you really is about how difficult is it to get started with these tool sets, given that they do a whole lot of things, and what might be the right way to start going there, to use them, so that the models can be, you can get better coverage when you're building more AI models. You can get better outcomes when you deploy those models, etc. So how does one go?
So we've tried to keep it pretty much agnostic of the problem and agnostic of the kind of data. So what we try to do is we try to work with on-prem deployment in our customer location, where they can take their existing model and they can work with their current test data, and if they're interested, even training data, and work our pipeline and generate the different components of the report. So we are creating a very simple entry point. Get your model, get your data, put it into our pipeline, and we will generate the whole set of reports and the corresponding data behind that. So there are two parts. There's a backend which generates the data, then there's a report generation which generates the audit report of that.
All right, cool. That's great. We have one question from the audience. Does AI have to be understandable to be ethical? Okay, now I'm presuming, and correct me whoever asked this question, that it is explainable probably to that extent to be ethical. I mean, and does the ethics and explainability have a correlationship there?
So there are some domains, probably yes, because if you look at explainability, what does it do? It tries to find in the input data which are the ones which are giving more importance, right? And if those are not handled, and those happen to be the sensitive ones, like the age or the gender, right? So then it is definitely a cause of concern. But otherwise, ethics is more about, are you being fair? Are you being fair? Explainability may be one tool to generate inputs into whether you're fair or not, but they may not be related directly.
Okay, so basically what you're saying is that the ability of the AI to manage, keep your information private, that it's not leaking privacy information, your private information. It is keeping your application secure. It is making sure that it's not leading you up some garden path, so to speak, through misleading feature set, amping up of certain feature sets as a part of the decision making. Probably that's what goes into the ethics, broadly speaking. And probably, as you say, it probably differs from one industry also to the other in terms of its applicability.
So I see there's one more question on, can AI be trained to differentiate between correlation and causation? This is a fairly, it doesn't have to be at AI level. It can be at statistics level, right? Because AI is an extension of statistics. So AI, what we do is we extend this typical statistical techniques, right, to get better regression or better classification. So even there, if you see the way some of the techniques which are purely meant for identifying relations between the data, it is more correlation oriented. Whereas if you look at from a causation perspective, people would use a different kind of an approach, saying that, can you draw a Bayesian network, which is more like, can I see this causes this? So I would say the techniques for both are different. First one is more like correlation is more a simple statistical thing, whereas causation would require very focused kind of machine learning techniques like Bayesian reasoning, etc.
Okay, all right. Anybody else? Any questions? I'll leave the floor open. While I just want to talk a little bit about Trigent and testing working together. We at Trigent are constantly on the lookout for tool sets that can possibly be applied in different contexts, right? It could be with the partnerships that we have with the larger tool sets that help us to our test automation. It could be in this very specific sphere, or it could be even in test design automation where we have a partnership with smart testing. So I think anything that we can do to help deliver a better or a more responsible test coverage is what we really look at, and tools like testing as AI ensured are what we help understand, package, and take to our clients bundled as a service. So if there are any queries on that, we'd be happy to take that up. Work with you all, help you all deploy these set of tools, deliver it as a service, or leave it to experience them. In fact, one of our customers that we have demoed this to is very keen to look at it, and hopefully that will conclude pretty soon. So if there are no more questions, there is one. Okay. Are there any guidelines about accountability for accidents caused by faulty AI?
The answer is it is work in progress. There are certain European governments who are trying to come up with a legal framework around it, but I would be very, very circumspect, because who would you blame? would you blame the guy who deployed the AI system, or would you blame the data scientist who trained the model, or you would blame the data analyst who collected the data? So I don't know what. So it's a fairly complex legal jungle we are working on. So very interesting question, but I don't think the answer is easily solved.
Requires a lot of intelligence and not so much of artificial intelligence, right, to solve that one.
Audit and each case-by-case analysis, right?
Yeah, I think so. I think it's interesting times. I think the progress of technology has reached a point where I was reading Ray Kurzweil's book of Achieving Singularity, and I think we are getting there much as he says, right? It's an exponential curve that we are on, and we're probably more up the curve than we even realize.
It's scary actually. Sometimes it's scary, the kind of, see, I'll tell you, 1956 AI was invented, but it's only in 2012 when deep learning gave the first significant proof of the fact that it can really scale neural networks to really large levels in dealing with images. And that's when the new AI has born, and it is just, I don't know, 9 years, and we're seeing huge transformation in the world. Pre-2012, there was an AI, but that was, you can say, AI of the previous generation.
Right. Yeah. Thanks, Srini. It's been a very, very educative, and very, very informative session. Loved your insights on all of these various things. And like I said, it's been a pleasure talking to you and interacting with you. So thanks a lot for your time, and
thanks for the opportunity. And look forward to creating a responsible AI for our customers.
Perfect.
Thank you.
Yep. Thank you. Thanks, everybody. Have a great evening, a great day, great evening, great afternoon.